Hello everyone, my name is Devin, and today's date is April 10th, 2026, and this is my video for FTT106 Week 3 assignment. And today I'm going to be going over caliper use, fastener identification, and proper torque application. I'll also explain how these skills connect to real gunsmithing work and why they matter. Alright, now I'm going to be showing you how to use the digital calipers properly. So what you're going to do first is turn on your digital calipers, and you're going to want to push it all the way till it's closed. You're not going to want to force this. That's going to cause your zero to be a little messed up. You're just going to want to bring it straight to the end and zero it out. Once you have full zeros across the screen, you can go ahead and select the object that you want to measure. In this case, we're just going to be measuring this case, specifically the thickness. So we're going to open up the jaws of the digital caliper, place them on either side of our object, and bring them together. And that's going to give us our reading for our thickness here. So our reading here for this thickness is going to be 792 thousandths of an inch. Now proper technique matters because even small mistakes can throw your measurements off. And in gunsmithing, small differences can cause big problems. Now I'll explain how to read dial calipers. With dial calipers, you read two parts: the main scale and the dial. The main scale gives you the base number. The dial shows the thousandths, and you combine both to get your final measurement. Now digital calipers are faster and easier to read, but dial calipers don't need batteries and are more reliable in some situations. A gunsmith might use digital calipers for speed and dial for reliability. Now, two examples where calipers are critical in gunsmithing are when measuring a barrel diameter or part fitment, or when you're checking screw or pin sizes. If measurements are wrong, parts won't fit, which can damage the firearm and make it unsafe. Alright, now we're going to be going over how we're going to read the outer diameter of threads and the thread pitch. So just before we get started here, there's a couple things that are going to be different between standard and metric fasteners. For instance, they are the same in how you read the outer diameter. We check here, make sure we're zeroed on our calipers. You're going to go from peak to peak on the threads the best you can. Spin it around, make sure you got a good reading. The outer diameter here is going to be 369 thousandths of an inch. Now, if you were to do the same thing on a metric fastener, you can also get the exact same outer diameter. Now, how metric and standard fasteners differ is going to be in the thread pitch. So on a metric fastener, to read thread pitch, you're actually reading the space between the thread. And we're going to be doing that with these thread pitch gauges here. However, on a standard fastener, instead of reading the pitch between each one of the threads, you're actually going to be reading how many threads make up 1 inch. Now, for these 3 bolts that we have laid out here that we're going to be taking for today's measurements, we're going to start off with the outer diameters of each. This one's outer diameter is going to be 231 thousandths of an inch. And this one's outer diameter is going to be 368 thousandths of an inch. Now that we know the outer diameter of each one of these bolts, we're going to be measuring the thread pitch. Now on this particular bolt, we are looking at a thread pitch of 26. Now this bolt is going to be a size 11. And we'll do the same with this one. And this one's going to be coming out to a size 20. Now there are challenges with this, one being getting an accurate reading on those small threads. Another issue is making sure the thread gauge lines up perfectly with your threads. Accurate fastener identification is important because using the wrong screw can strip threads or damage your parts. For example, when replacing a scope mount screw, you need the exact size and pitch or it won't hold properly. Alright, now we're going to be going over torque specs. Now for this, I'm just going to be torquing down the handguard on the Sig Spear LT, and I've already done my due diligence by checking the torque spec recommendations on Sig's webpage. And in this case, this handguard specific fastener here is spec'd out at 45 inch-pounds. So what we're going to want to do is grab our torque screwdriver. In this case, we're going to be using our Real Avid one. So we're going to start by taking this fastener and just setting it inside. I just like to get the thread started. When you start the threads by hand, you have a less likely chance of stripping those threads by forcing it with your screwdriver afterwards. But then we're going to take our torque screwdriver here and we're going to set it to 45 inch-pounds. Now to do this, you can notice on this Real Avid one here, you have a little indicator line down here that's going to be telling you what you're set at. So you're just going to be spinning this dial until you get it to 45 inch-pounds. So I'm going to take this back to 45 inch-pounds there. I've already got the proper bit selected, in this case a T15, and we're going to be tightening this down. Now once it gets snug, you're going to slowly twist until it breaks. And now that that broke, we know that is now properly torqued to 45 inch-pounds. Inch-pounds are smaller units used for precision work, while foot-pounds are larger and used for bigger components. Now torque is critical in gunsmithing for multiple reasons. More specifically, scope mounting screws, action screws, barrel nuts, etc. Now there are consequences, however. For example, over-torquing can strip threads or crack parts, and under-torquing can cause parts to come loose during firing. This can affect accuracy, function, and the overall safety of the firearm. Now precision is everything in gunsmithing. If your measurements or torques are off, it affects performance and safety. That also affects your reputation as a gunsmith. When working on an unfamiliar firearm, I would measure everything carefully and verify specs before doing any of the work. And for custom parts, precision tools like calipers, Torx drivers are really required to get everything right. Overall, these skills are important because they help ensure firearms are safe, accurate, and reliable. And with that, thank you for watching.